Hello everybody, thanks for stopping by the channel. You can see I'm sporting my new Ox Tool jacket. Hey, we're going to have a nice video today, and I think you're going to enjoy it, and I really appreciate your time. Uh-oh, hey, come on, there's the bell, we're going to be late for the class.
Okay, here we are again in Carl's shop. I got a few things to show you today. This is a flame licker or a vacuum engine when it's operating, and unfortunately this one doesn't operate yet, and we'll talk about that. It has a alcohol lamp, a wick, and flame is ingested into that port, and the flame products condense in here and create a little vacuum, and this thing is supposed to run. As you can see, it has too much friction, doesn't pass the friction test. And in investigating it, I found that the axis of the cylinder is not square to the axis of the crankshaft. I have no idea how that happened, but I'm going to disassemble this, remachine the bed plate, and see if I can get everything squared. Now, during the disassembly, I have to take the piston off. And one of the handiest tools that I have are these ball-ended Allen wrenches, because I can reach it at an angle. So we're going to show you, I assume everybody knows about the ball wrenches, so I'm going to show you anyway. They allow an angular approach to the socket of the socket head cap screws. Extraordinarily handy. I prefer the screwdriver type over the bent type, but then at times I use whatever is handy. Okay, there's that.
I just got to add something there, Carl, real quick. Steve Summers, who's one of the YouTube guys, he was showing a very small ball nose, and he was getting a set screw out that was behind another set screw down in a bore, and he's reaching in there, and he goes, oh, the ball just broke off the end of the tool.
Yeah.
And he was fortunate enough to put a neodymium magnet on a piece, reach in and got the ball back out. But, yeah, so just a warning for people, for the small guys.
So when I'm working, I'm going to disassemble this, and when I'm doing that, I work right here with a jeweler's tray. Now, maybe some of you haven't seen this, but this is one of the handiest things, because when small screws or bits and pieces come out, I tend to drop things, and when they go on the floor, it's a half-hour search trying to find them. So it's just a piece of canvas in a wooden frame, secured on the back by little cleats, and I use this thing extensively. The other thing I use when working on small items are these fingerless gloves, manufactured by Memphis Glove. Chuck will put a link up to their website, and you can, if you're interested in them, you can go look for them. Made out of Kevlar, PVC grippers, but the nice thing is they leave your fingertips, just the last portion of it, uncovered, and they're just extraordinarily handy on small work, because you still have the finger dexterity. You have the warmth and protection of the Kevlar glove. I love these things. I use them, wear them out, throw them away, buy them in packages of 10. Just a wonderful glove. The only thing is, there sometimes can be a challenge to get off. Okay, I told you earlier that the axis of the cylinder is not square to the axis of the crankshaft, and then I have a shim in here that corrects most of that. And I want to show you one of the handiest things that I've done years and years ago. Was I took apart two sets of thickness gauges, feeler gauges, and I put two sizes. This is the says 19 and 18 and 19. I put them in a coin. Coin whatever. You'll think of it.
Envelope.
Yeah, coin envelope. Thanks, Chuck. And I rarely use the full set where everything is all pinned together, and I'm going to use these to shim up the base plate so that this indicates level to the table of the mill, and then I will machine this surface off using the mill. And the last shop tip, I assume everybody knows this, but I'm going to show you anyway. Right there, Chuck, you got it? If you're looking for small parts on the floor, do that.
Get the shadow, huh?
Yeah, it's better. It gives you more, it gives you some visual contrast, gives you something else to look for. Better than going down looking around like this is you look around like that, because you'll see the bright spot and the shadow. So there's a handy tip for you guys.
I like that.
Okay, I said I can't show you this engine running, but I can show you a little bit about how this, and this were made. So we'll move over and get started on that.
Let's see.
Hey Chuck, what is this thing?
Everyone knows that's a whiteboard.
Yeah, okay, yeah, it's a whiteboard, but for me, this is my board prompter. The pros have a teleprompter. I've got a board prompter.
Well, I don't know, all that writing looks like school to me. I'm getting bored already. Hey, when does the recess bell ring around here?
Okay, let's get going. Up here in the right-hand corner, and Chuck's going to zoom, pan up on that. We're going to look at the three of the pieces that are used in the vacuum engine. They were done as castings, and one of the interesting things about castings is that they are near net shape. You can put exactly the amount of metal in exactly the right place you want, and this is a EMT bender is a good example. It would be difficult to machine this out of a block of aluminum. You'd have a lot of waste. Perhaps today they might attempt to do this in 3D metal printing, but there's still a question of, is it strong enough? The only material that is removed after this item is cast is to bore this hole and thread it for a piece of 3/4 conduit. So that's a major advantage of casting, is it gets near net shape. There is, Chuck does additive manufacturing, takes PLA resin in a string and spits it out into exactly the shape that's specified by a CAD drawing. And then there is subtractive machining, which a lot of us do in machine tools. There are a lot of chips, we throw a lot of metal into the scrap. The process of casting is making a hole in the sand of the correct shape and pouring molten metal in. Now we're going to start over here on this side. If Chucky will pan in here. It starts with the engineer or the designer. I've got a humor. The designer sat at his drafting board. A wealth of knowledge in his head was stored, like what could be done on a radial drill or a turret lathe or a vertical mill. But of all things, a knack he had for driving gentle machinists mad. So he mused as he thoughtfully scratched his bean, just how can I make this thing hard to machine? If I make this perfect body straight, the job had ought to come out first rate. Would it be so easy to turn and bore that it would never make the machinist sore? So I'll put a compound taper there, and a couple of angles to make them swear, and brass would work for this little gear, but it's too damned easy to work, I fear. So just to make the machinist squeal, I'll have him make it out of tungsten steel. And I'll put these holes that hold the cap down underneath where they can't be tapped. Now if they can make this, it'll just be luck, because it can't be held by dog or chuck. And it can't be planed and it can't be ground, so I feel my design is unusually sound. Then he shouted with glee, success is last, this damn thing can't even be cast. And the truth is, that casting can produce some things that cannot be produced by any other method. I'll show you one at the very end. So the process, get over here Chuck, the process starts with a designer, and then a pattern maker makes a representation of the shape in some material and passes it off to the molder. The pattern maker makes the shape of the hole. The molder makes and fills the hole in the sand. I'm going to show you one of the processes that is used in the foundry, and it's a process that I use to making my parts. It's called cope and drag molding, and if Chuck will go down here to the box, I sold most of my casting stuff, and so I had to fake it. And these boxes represent the two parts of a flask. They are a flask is comprised, has no top, has no bottom. So the boxes are open, and they have some kind of alignment pins to make sure that they go back the same way and accurately located. Those parts are missing on this. So cope and drag molding, two open boxes, and that comprises a flask. The joint between the cope and the drag is the parting line, and that is this piece of cardboard here. And so we're going to take the cope off. We'll get rid of the parting line, and we're going to start with the pattern. This is the shape. This is the shape of the hole that we want for the finished piece. And in the black and the red pieces out here are channels through which the molten metal is poured. Now this particular pattern was molded in the drag like this. And some pins were put on like this. And in this particular case, molten metal is poured down into here, runs through the hole, the cavity, and we need some means of getting the air out and also of letting the molder know when the hole is full. And so there are two risers, and the metal runs up here, and when the molder sees molten metal at the top of this, he quits. Now these two pieces are larger than this, and there's a reason for that, and that is that as the metal cools in the cavity, it tends to shrink. And so these two pieces supply hot metal, and as this shrinks, it pulls metal down into the cavity, and you'll wind up sometimes with a fairly deep a hole in the top of the risers. So the process is, you start with this upside down, and you fill this with sand, and you pack it in good and hard, and then you put this on the top, and you pack it full of sand, and then to get the pattern out, you have to split everything at the parting line. So you take the cope off, you go tappa, 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 and you lift the pattern out, and you put the top box back on. And now there's a hole here, and a hole here. Pour the metal in here and watch for it to rise up here, and then you quit. So this particular pattern is a one piece, flat back. So the parting line is going to be here, and this bottom surface sits on the parting line. This flywheel was done in a two-part pattern, and the parting line is right through here, right through the center of this, and it goes through the center of the spokes. And so if you look at the pattern mounted on a board, here is one half of the flywheel. Here is the other half of the flywheel. And because this is a two-part, these come apart, and so when you do the pattern making, you have to have pins that make sure that when you put it on the board or mold that the alignment is maintained. Again, there are additional parts that for running the metal in. Metal goes in here. It pours the crank disc and the flywheel. Now that we know a little bit about the parting line, we can look at a little more complex casting and try to figure out where the parting line is. And so looking at this, we think, well, because this is round, the parting line has to be here. And it has to be like that. And then we can follow the parting line down through here, down here, and down to there. And so quite probably this was an additional, this has been machined, was probably at least that much longer. And would have been molded in the drag, or I don't know which way this would be molded, up or down. But the main thing is I want you to be able to pick up a casting and begin looking at it to see if you can figure out the parting line. And in this particular case, on one of the spokes, you can see just the vestige. There's just a vestige of a parting line in here, which you won't be able to see on the video. Now the parting lines don't have to be absolutely flat. They can be a little more complex. This is a knob that Delta used on their woodworking tools, and it is my favorite small hand knob. I really like this. It's very easy to grip, positive in action. I like this. I've made a bunch of them. So I took one off of a machine and made a casting from it. I knew that the parting line was here, so I put this down in the sand, and I parted this and did a couple of things, and I was able to make this casting. And then to do a bunch of them, I made this little board, set the casting in it, and then poured plaster around it to exactly the height of the parting line. And now I have created a parting, and that sits on top of the flat parting line, and this goes like that. Pound the sand up, and when you take this out and you take this out, we now have a hole, and this shape to support this while sand is packed around it. Now, Chuck, if you'll go back up here to the top, the requirements of the molder, how he gets the pattern in the sand, out of the sand, how he gets the metal in, drives what the pattern maker has to do to create the shape of the hole, and further designs what the engineer can and can't do. So he has the shape. He has some control over the shape, because there's just some things, you know, be far too difficult or too expensive. So again, the requirements of the molder may drive the work of the pattern maker and the engineer. I want to show you last what would be a journeyman test of molding, and this is a saucer, cup, and teaspoon. Now we can look at these one at a time. If we were to look at this, we could say, well, sure, there's a parting line right through here. Horizontally, right through here. We can get the bottom half out, we can get the top half out, no problem. If we were to look at this, well, we can follow a parting line starting here, going down through there, and coming like this. So if we were to do this vertically in the sand, we could get it out. But this parting line and this parting line are at right angles to each other. So you cannot mold this combination at the same time. It doesn't work. You really make it complex by putting a teaspoon in there. There is no parting line. There's just a multiple set of problems. How you form the shape underneath the spoon, and then up around in here, and at the same time being able to get the saucer out. Remember, this is all done by hand. You ram up some sand, and then you do something, and then you do something else. And one time I had a book that showed how to do this. It was 50-some steps, and what they do is you ram sand over part of it, and then you put a parting compound on it, you make another bed of sand, and you do something on that, and there are multiple pieces that in the end are assembled together to make this. And this can be successfully cast, but it is a tremendous challenge. So, I think that is everything. Let me look at my lesson notes. Yep. Okay, I hope you enjoyed this one. Thanks so much for watching.
Carl, real quick.
Yeah.
I didn't take notes. Is there going to be a test?
Yeah. I can write up a test for you. Sure.
I want to pass the class.
Yeah. You want to pass the class?
This is my first time.
Yeah. Well, I tell you what. Chuck was asking if when recess was.
Yeah.
And so I have a bell over here.
There we go.
We're going to ring that bell for recess.
There we go. Ring that son of a gun. I'm hungry. It's lunchtime. Thank you, Carl. Great job.
Hey, Chuck. What is this thing?
I don't know what that is. What's the purpose of that? I can't remember.
Kill that. Start over again. Or you can do that as an outtake.
You got to give me a script. You have to write all my script?
I did.
You did, thank you.
All you have to do is read it now.
You think I can read too? I still don't like this one. And we're going to head over to Carl's, and we'll have a nice